Hi friends, welcome back to my channel. This is Syed Reshma Sharif. In this video I am going to solve Polytechnic mathematics question paper along with answers. Here I am not going to write clearly questions. Okay. I will put all this question paper along with answers in my description box. Let us go through with the description box. Here just I will solve all these problems. In first section, what they gave matrices that which is equal to 2, 0, 0, 0, 4, 0, 0, 0, x. Okay, it is given is equal to 8. And what we have to do, we have to find x. This is a given matrix which is equal to 8. In question, they gave this one. Now, first of all, expanding the determinant. Okay, now I am going to expand it. Expanding the determinant is nothing but here this one 2 into this one 4x minus 0 minus 0 this one into this one 0 into x minus 0 into 0 minus 0 into this one 0 into 0 minus 0 into 4. For your understanding this step, I am going to write this one. No need to write if 0 is means 0 into anything 0 only is equal to 8 they give. 2 into 4x minus 0 is equal to 8. 2 4s are 8x minus 2 into 0, 0 is equal to 8. 8x is equal to 8. X is equal to 8 by 8. 1. X is equal to 1 therefore. This is the required answer. Find x or not. In 1a only they gave another problem. If you can solve this one or that one, it's your wish. Okay. Now for a matrix, A is equal to 4 minus 3 minus 5 2. What we have to find? We have to find adjoint of A. See ma here. This is very simple. Little logic and one simple sentence. If you remember this one, it is very easy to write adjoint of A matrices. Okay. Actually, what is adjoint matrices means? This one remember carefully. Interchanging the principal diagonal elements and changing the signs of secondary diagonal elements, we get adjoint of A. See ma, in this sentence only, interchanging the principal diagonal elements. Diagonal elements are nothing but this one and this one. These two are diagonal elements. These two and these two. Here first of all, interchanging the principal diagonal elements and changing the sign of secondary diagonal elements, we get adjoint of A. First of all, what we have to do, we have to interchanging the principal diagonal elements and change the sign of secondary diagonal elements. Then write adjoint of A is equal to interchange first elements 2 diagonals 2 4. Here secondary elements we don't have to interchange them, but we have to interchange their sign. Here minus 3 is there, so I am going to write plus 3. Here 5 is there, I am going to write plus 5. Minus 5 is there, so I am going to write plus 5. This is adjoint of A. Or we can find in this problem, or else we can solve like this only. We are given that A is equal to 4 minus 3 minus 5 2. Now what we have to write, we have to solve adjoint of A. We have to find adjoint of A. Directly we can write this formula, we can write this one, and we also solve like this, or else we can find cofactor of each and every value. Okay, if we find cofactor for each and every value, and if we write the cofactor matrices transpose, that is called adjoint of A. First of all, cofactor of each and every one, cofactor of 4 is equal to this one 2. Cofactor of minus 3 is equal to diagonal element but interchanging their symbols is equal to 5. Here transpose means nothing but interchanging of rows and columns. Here the cofactor of matrices is given by 2, 5, 3, 4. 2, 5, 3, 4. 2 by 2 matrices. Adjoint of A is equal to transpose of cofactor of matrices. Here transpose is nothing but interchanging its rows and columns. See how I am going to interchange rows and columns. 2, 3, 5, 4. Okay. This is adjoint of A. Here nothing difficult, it is very simple, but just a little logic is there. That one we have to remember in our mind. Don't forget. See, this is interchanging principal diagonal elements and changing the sign, that is secondary diagonal elements. See, here I am going to find cofactor of elements. Cofactor means first element, right? Similarly, this diagonal, cofactor of second element, which is equal to diagonal, interchanging its sign. See, third one also. Only second diagonals only we are going to change. This one, see, these two are second diagonals. First diagonals just I am interchanging. Second diagonals interchanging the signs. Okay, that is a logic. Don't forget that one. Okay. Next problem is that in a mesh analysis formulation, the following equations are obtained as 4I1 plus 2I2 is equal to 4. And next one is given by I1 plus I2 is equal to 2. Obtain the currents I1 and I2 using Cramer's rule. Now this one is given 4I1 plus 2I2 is equal to 4. I1 plus I2 is equal to 2. Now delta is equal to 4, 2, 1, 1. Okay, this one 4, 2, 1, 1. Anything here I1 is there means 1 is there, 1 into I1 only na. Here also 1 is there na. So that's why I am writing in this one. Okay, now determinant 4 ones are 4 minus 1 twos are 2 is equal to 2. Similarly, delta 1, delta I1 is equal to, here the 4 and 2 are there na, in equation they given. Now delta 1 means in, this is our main matrix, from this one we derived. In this place we have to interchange this one 4 and 2. Understood? 4, 2. This one in 4 1 and 1's place I am going to write 4 and 2. 2 and 1 same, because it is delta 1 I1. So in first row only I am changing with 4 and 2. In question they gave na, with that one I am changing. Is equal to same diagonal 4 ones are 4, minus 2 2s are 4 is equal to 0, delta I1. Next, delta I2, say delta I2. In which place I am going to change? In delta I2 means second row, isn't it? In this place I am going to write this 4 and 2. Same 4 and 1 I wrote. Here inside 2 and 1's place I am going to write 4 and 2. Similarly 4 2s are 8 minus 4 1s are 4 is equal to 4. Okay. Now current I1 is equal to delta I1 by delta. What they gave in question? They gave that find current I1 and I2. So for this we are going to find delta I1 is equal to current I is equal to delta I1 by delta. Delta I1 which one? 0. By delta value how much? 2. 0 by anything? 0. Sorry. Next one, current I2 is equal to delta I2 by delta. That is equal to delta I2 how much ma? 4. 4 by delta value how much? 2. 2 1s are 2, 2 2s are 4. Answer is 2. See how we get currents I1 and I2. I1 is equal to 0 and I2 is equal to 2. Here nothing difficult in this problem. Listen carefully. Here what they gave? They gave two equations which is in 4I1 plus 2I2 is equal to 4. I1 plus I2 is equal to 2. By using Cramer's rule they gave means, first of all we have to find delta. Delta means just write complete matrices from equation I am writing. And delta 1 means interchanging first row with this one and interchanging second row with this one. Like that, after that we will find current means delta I1 by delta, delta I2 by delta. So I1 is equal to 0 and I2 is equal to 0. Don't miss any logic in this one. See, very easiest one. Don't get fear. How much you prepare for exam, that much effort to put for your exams. Next, or else 1b. In 1b, we can solve this one also. Now what they gave? They gave matrices A is equal to 1, 2, 1, 4. And B is equal to 3, 1, 2, 1. Find the product of matrices A, B. And hence find the inverse matrices. Inverse matrices, if it exists. Now this is given. Now what we have to find? We have to find AB. I am not writing completely question mark. Please go through my description box. We will get question as well as answers. Here what we will get? A is equal to this matrix of B is equal to 3, 1, 2, 1. Now AB. Two matrices multiplication 1, 2, 1, 4 into B 3, 1, 2, 1. Okay, how we will multiply? Let us see. First column with first row, second column with this one. Okay, is equal to 1 into 3 plus 2 into 2. Similarly, this one with this one. This one with this one. 1 into 1 plus 2 into 1. Similarly, this one into this one, 1 into 3 plus 4 into 2, and this one with this one, 1 into 1, 1 into 1 plus 4 into 1. Okay, clear ma? 3 plus 4, 1 plus 2, 3 plus 8, 4 to the right, 1 into 1, 1 plus 4 ones are 4. 3 plus 4, 7, 1 plus 2, 3, 8 plus 3, 11, 1 plus 4, 5. Now this is AB, multiplication of this matrix. This is how means not very difficult. AB means, see, first of all this row with this one with this one, okay, and after that this one with this one. Similarly this one with this one, this one with this one. That is main thing in these matrices. Don't forget all those, okay. That is AB is equal to this one. Now what we have to find? We have to find inverse of this matrix. If it exists or not, we have to find, okay. Now consider AB matrices. Determinant of AB is equal to 7, 3, 11, 5. Now determinant means this one and this one. 7 5 is 35 minus 11 3s are 33 is equal to 2. Okay, which is not equal to 0. Therefore, determinant of AB is non-singular matrix. This is a condition. If the determinant of AB is not equal to 0, then inverse of that matrix will exist. In question what they ask if it exists or not, we have to find first of all, and then we have, if it exists means we have to solve that one. See here, so these matrices will exist. Now AB inverse is equal to 1 by determinant of AB into adjoint of AB. AB inverse is equal to this one, you have to remember. AB inverse is equal to 1 by determinant of AB and adjacent of AB. So here AB matrices we know, 1 by AB determinant we know, 2 we get determinant. That equal to 1 by 2 adjoint of AB. Adjoint of AB is nothing but interchanging their diagonal elements, first diagonal elements 5, 7, and changing their sign of without interchanging the second diagonal elements, minus 3, minus 11. See, only I change first diagonal elements only, but second diagonal elements I won't change, but I change its signs, okay. Minus value I wrote. This is our required AB inverse. Understood? Another one, see, they gave that if characteristics roots of a matrix A is given by 2, 3, 0, 4. Given that A is equal to this matrices 2, 3, 0, 4. We know that characteristic equation is a minus lambda I is equal to 0. Now determinant of a minus lambda I is equal to determinant of this matrix as 2, 3, 0, 4 minus lambda value into I means identity matrix 1, 0, 0, 1. Why I am taking 2 by 2 here? 2 by 2 matrix is there or not? So I am considering this 2 by 2 matrices only. Equal to 2, 3, 0, 4 minus lambda into 1 lambda, lambda into 0, 0, lambda into 0, 0, lambda into 1, 1. 2 minus lambda, 3 minus 0, 0 minus 0, 4 minus 1. First row first element with this one, second row second element with this second row second element, third row third element with third row third element, fourth row fourth element with this one. Like this we have to subtract. 2 minus lambda is equal to 0. 2 minus lambda, 3, 0, 4 minus 1, 3 is equal to 0. We have to find lambda value, isn't it? 2 minus lambda into sorry, I wrote forget to write determinant. Determinant is there, isn't it, or not? All the operations and after the determinant will be there. So I am writing determinant value. Now we have to find 3 not 3 here, 4 minus lambda, 1 here, 1 into lambda. 2 minus lambda into 4 minus lambda minus 3 is equal to 0. 3 into 0 is equal to 0. 2 minus lambda into 4 minus lambda is equal to 0. 3 into anything, 0 only. Here 2 into 2 square, a minus b into a minus b whole square or not? 2 square minus lambda square. Or we can solve like the 2 4s are 8 minus 2 lambda minus lambda 4 lambda minus into minus plus lambda square is equal to 0. Lambda square minus 6 lambda plus 8 is equal to 0. This is our required characteristic equation. Till here we find characteristic equation, but in question what they ask to solve characteristic, to find characteristics roots. Now the value for this one is lambda square minus 6 lambda plus 8 is equal to 0. It is required characteristic equation. Lambda square minus 6 lambda plus 8 is equal to 0. Okay, this is our characteristic equation. From this I am going to consider lambda minus 2 and lambda minus 4 is equal to, from this I am going to, from this equation I am going to factorize this equation. What we will get, 8 lambda square minus 6 lambda plus 8. Here if you solve this one with this one, how we will get 8 into lambda square minus 6 lambda plus 8. Here lambda I am going to write lambda square minus 6 lambda can be written as minus 4 lambda minus 2 lambda plus 8 is equal to 0. This is a factorization, ma. Lambdas, how we will going to solve this one? We have to factorize this equation. Now here in this place 6 lambda, lambda is there. If you write 4 lambda minus 2 lambda, it will be correct or not? Minus 6 lambda. Now 8 into lambda square. The value we have to get 4 2s are 8. Value also we have. This is factorization. Here lambda I am going to take common. 1 minus lambda minus 4 minus here 2 I am going to write common. Lambda minus 2 get common 4 is equal to 0. Then lambda minus 4 into lambda minus 2 is equal to 0. Lambda minus 4 is equal to 0 and lambda is equal minus 2 is equal to 0. Lambda is equal to 4 or lambda is equal to minus 2. Okay, these are the characteristics roots. Lambda is equal to 2, lambda. This is factorization technique. You will learn all this factorization in our 8th class, 7th class. After 7th class, I think after 7th class, you will learn this factorization method. Okay. Here I am skipping one problem. After that, I will solve the problem. Now, let us see D. If A is equal to 2, 1, 4, 4, 1, 5. B is equal to 3, minus 1, 2, 2, 1, 3. Then can we perform AB and BA? Can we perform AB and BA? If so, write the order of AB and BA. Now, given matrices is this one and this one. This matrices is of 2 by 3 matrices. This is of 3 by 2 matrices. Now we know that for matrices multiplication, number of columns of matrices should be equal to number of rows of second matrices. Now consider AB is equal to 2 into 3, 3 into 2. Here the number of columns of matrices A is 3 and number of rows of matrices B is also 3. Hence we can perform AB. Also the order of AB is 2 by 2. First of all, in this question they ask is we can perform AB and BA or else which is the order, what is the order of A and B? We have to write, that's all. No need to solve this problem. Okay. Is it possible or not? We have to write in this one. First matrices is 2. AB. A matrices 2 by 3 matrices and multiplication of 3 by 2 matrices. The number of rows in matrices or number of columns of matrices A is 3. Here number of rows of column B is 3. Matrices B is 3. Okay, so we can perform the matrices AB operations. Okay, and its order will be is equal to 2 by 2 matrices. Similarly, BA matrices 3 by 2, 2 by 3 matrices, isn't it? Matrices multiplication is that number of columns of first matrices it should be equal to number of rows of second matrices. 3 equal or not? Column with the second row of second matrices. If this condition will satisfy means we will definitely perform operation of multiplication, and the order of these BA matrices is equal to 3 by 3 operations. Okay, the simple logic we have to remember here. Once again I am saying, see how when the multiplication is possible, number of columns of first matrices is equal to the number of rows of second matrices. Columns of first matrices is equal to the columns of second matrices, rows of second matrices. Similarly, for this one also, number of columns of first matrices is equal to number of rows of second matrices. Then that matrices will be formed, that order will be formed. Here 3 columns, 3 rows, so 3 by 3 matrices will form. Here 2 columns, 2 rows, here 2 by 2 matrices will be formed. Okay, the order of this one and this one is 2 by 2 and 3 by 3. That's all, very simple. Next problem is, if the matrices A plus I is equal to 0, where I is identity matrix. Of order 3 by 3 and 0 is null matrix. Order corresponding to matrices A. Then find A. See, in given problem what they gave, consider that A plus I is equal to 0, where I is identity matrix of order 3 and 0 is null matrices they given. Consider A plus I is equal to 0. If to find A, subtract both sides with identity matrix 1 of order 3. A plus I minus 1 is equal to minus 1. If this minus get cancelled or not, so it won't change. So we are considering just minus 1 on both sides. Then A plus identity matrix 1 0 0 0 1 0 0 0 1, 3 by 3 matrices. Okay, is equal to 0. A is equal to minus of identity matrix I 0 0 0 0 0 1. Then A is equal to here why we are considering minus 1 and minus 1 means for order 0 is a null matrix in order to corresponding matrices A. Here, so that's why we are considering A plus I minus 1 is equal to minus 1. No need to consider. If you consider also, no problem. We know identity matrix or not. So we are writing A is equal to, if this matrix moves to that side, it will become minus. With minus, multiply with minus, minus 1 0 0 0 minus 1 0 0 0 minus 1. Therefore, this is a corresponding matrices A. Then find A means we will find A. This is up to section 1. Thank you for your watching. If you have any doubts regarding this, please comment me on my comment section. Thank you.